As in the previous discussion, we were discussing about the static and the dynamic analysis of source code for any of the Android app. We had a thorough demonstration on MobSF, that is Mobile Security Framework. We saw how can we use it for performing static analysis, how can we use it for performing dynamic analysis, how do you generate the report, how do you read the report, and what would be the next step that you will be taking. That is what we discussed yesterday. Now, what we have to discuss today is more related to source code. When in any of the application, there will be any of the functions, that will be root cause of the security issues. Functions here do not necessarily specify the name of the function, but functions here means those practices or configurations or those specific methods that can be misconfigured. There can be some of the practices that are being followed that are a threat or maybe a challenge to the security posture of the application of the platform. That is what we have here. So for the sake of this discussion only, I am giving you a theoretical introduction to them, because those specific classes that we have, like when any of the application is using insufficient cryptography or entropy. So for all of those topics, we have dedicated modules wherein we will be discussing about them in detail, both theoretically along with the practicals on the live Android apps. So for now, just so as you have an idea, I'll be giving you a theoretical introduction, and to save everyone's time, I have written this down so I can simply make you understand that this is what we have. For all of these, we have dedicated modules wherein you will be having these security issues, how do you test for them, and we will be having live Android apps wherein we will be looking for the security issues. I'll test that application live, and I'll also take you to the source code. I'll decompile the APK, I'll take you to the source code, and I will show you the specific lines that see on this application, in this file, in this line, this is the root cause. I will also show you the approach that in any of the app, how do you have to find out that vulnerable code? How do you get to the root cause of that security issue? What all keywords you have to search? We will be discussing them. So for now, only for the sake of today's discussion, I'm giving you a theoretical introduction here. I could have skipped it because anyways we will be discussing this in the upcoming session in detail with theory and practical, but we are discussing this theory here also, so that when in the upcoming discussions, when we are discussing it, you already have an idea that this is what we will be discussing here. So at that time when we will be discussing in detail, you will be able to understand things better. So here, like there are five major things that we will be looking for when we are looking for the vulnerable functions in any of the APK. These are the five major vulnerability classes as we call it. The first one that we have is the insecure connection. Insecure connection means when that APK or when that particular application is interacting with any of the server, that connection, that should be over a secure channel, that should be over the encrypted channel, so that the particular data that is being transmitted over the network, it is not vulnerable to man in the middle attack. Even if in case anyone is able to see the data, anyone is able to intercept the network, they are not able to see the data that is traveling, they are only able to see some jumbled words, the encrypted data. So you should be having the secure connections. Like here, how do you look out for the insecure connection security issues? Like in the complete source code, you can look out for the keyword like HTTP. What you need to do, the APK that you are testing, with the help of 𝗧𝗿𝗶𝗶, you first of all decompile it, you can directly run this command, and then in the complete source code, you search for HTTP, or you search for codes or protocols like HTTP or FTP or SMTP, like this. These are some of the examples of the insecure protocol. So if in the code you get HTTP or FTP or SMTP, this means that the data that will be traveling, it will be in the insecure connection. It can be seen in the clear text when intercepted. So you take a screenshot of that code, and you send it to the developer that here HTTP is being used or insecure protocols, insecure connections are being used. Please do not do this, fix it and switch yourself to a secure alternative, the encrypted alternative. We have to get all of the connection over HTTPS over the secure channel. First priority should be given to the sensitive data. Sensitive data is in when in the request credentials are going, private information related to the users are going like their email ID, their credit card information or any of the API key is going, all of the data that can be considered sensitive, private or personal to the user, that should be encrypted. That is the first priority. Anyways, at the end of the day, all of the data that is being transmitted, that should be happening over the secure channel. But when it comes to fixing, first priority should be to the sensitive data. This is what you have to do. I have specifically mentioned authentication over insecure protocols because usually the pen testers or the bug hunters, they tend to miss it. So for that reason, I've explicitly mentioned it so that you double check. You can also use this as a checklist that when you are performing the code analysis, you can look out for these issues, that whether any of the application is sending the request over HTTP or over FTP or over SMTP or any of the other insecure protocol that the application architecture might be having. These are just some of the common examples. Especially the authentication should be happening on the secure channel over the encrypted connection. And here these are the recommendations that if on any of the application as a pen tester or as a bug hunter you get to see that this is the security issue related to insecure connection, so what do you recommend? First thing that you should be doing is that the function that you are using for making a request to the server, this should be the function. This is one of the functions that we have in this particular library javax, that is javax.net.ssl.https URL connection. You need not remember the name. I'll be sharing these notes with you. You can always refer to them. With time, the more you will be revising it, more experience you will get, more practice you will do, you will anyways be able to remember it. So no need to mug this name up. Simply keep this thing in mind that when you are using any of the function or you are using any of the library, make sure that the HTTP connections that you are making, that is over HTTPS. So this function, this will be making the request to the server over HTTPS as the name suggests. So try using it much more as compared to HTTP URL connection. Use HTTPS URL connection. Also, if you are using Android P or above, so on all of those Android versions that you are having Android P or above, if in case you make any of the request over the insecure connection in the particular Android manifest file, in that particular configuration, you will have to explicitly mention that this particular application will be using the insecure connection because of, like, you need not mention the reason, but you just have to get yourself an exception. Why is that being done? So that if in any of the application by mistake any of the developer has missed out on HTTPS, they have only written HTTP, Android version, Android operating system itself will block all of the requests that are going over HTTP. In a lot of cases, it will happen that your client or the application, they do not have HTTPS. Their servers themselves are running over HTTP. They do not have HTTPS available. So in that case, they might want to make the request over HTTP. So if it's the demand of the situation that you cannot send a request over HTTPS, you should always be making sure that if you are using that application or Android P or above, you should be making that an exception in the Android file that here we will be making this request over an insecure connection. Please allow it. Otherwise, by default, the Android operating system will be blocking that request and that request will not be made to the server because it is going over the insecure connection. So that is one thing. But because as I mentioned it in the previous discussion, that if any of the application that you are testing, you test it on the minimum SDK. Like if that application can run on Android 6, you test it on Android 6. If minimum it can run on Android 7, you test it on Android 7. You do not test it on the latest version of the Android, because we would be testing it from the approach that all of the security implementation that the Android operating system offers, all of them have failed. The attacker, the adversary, they were able to bypass it, and now we have to make our application robust. We have to make our application persistent for the security attacks. Our application itself on the code level should be so secure that the complete application, even if in case everything else fails, the application itself is able to withstand against all of the security issues. So for that reason, though this is what happens by default, I would not want you to rely on this, that everyone is using at least Android 13 or at least Android 14 to do. So that will already be taken care of. Please don't do that. Your focus should be on making your application more secure. That is more important. So no matter what other security implementations are there, consider everything else has failed. And with that consideration in mind, you should be doing the review or the audit of your application. So this is what you do for insecure connections. As I mentioned it previously, we do have modules dedicated to insecure connection. We will be discussing this in practical, and this theory will also be again discussed in detail. I will take an APK. I will show you the approach that if this APK is to be tested for insecure connection, what you do, how do you decompile, what are the various keywords that you look out for, how do you look out for the keywords, how do you take a screenshot, how do you report. We will also be having a look at HackerOne reports, that this security issue that we are about to discuss, this researcher reported this and this much bounty they received. So you get an idea what is the worth of the security issue that you are learning, how impactful it is, and how the organizations will be considering that security issue. Then we have got security issues related to cryptography. It simply means that whenever you have got any of the sensitive data, it may be the personal information related to the user, it may be the private or the authentication API keys or token. For example, on your application, you are using Firebase as the backend database. When you were developing the application, you hard coded the API key or token for Firebase in your Android app, and you released it to the production. You released it on Play Store. Anyone can download that app. Anyone can extract the APK from that app, and then they can decompile and they can get your private API key in the source code. So for that reason, what we do with the help of this word list, like if you go to this GitHub repository here, if you go to bug bounty word lists, here you will be able to find the most common keywords that will be containing the sensitive data. You go to word lists, you scroll down, and you will have GitHub docs for secrets. These are the names of the most common, uh, you know, the variable names that can contain any of the sensitive data, like AWS access key ID, AWS secret key authorization token, app secret, app key, app secret key, app secret, like this. So you can use all of these keywords and then you can search for them in the source code. So if they contain it, they might be containing some of the sensitive data, and then you can take a screenshot, send it to the developer that in your code, in this file, on this line, this private API key, this private token, this sensitive token is hard coded. Please don't do that. Please remove this from the upcoming versions of the code, and also to be on the safer side, please rotate this API key, change this API key. That is absolutely necessary. So here, this is what we have. For any of the application that you have, if you are using any of the third-party API, maybe from Firebase or maybe from GitHub or any of the other third-party APIs that you have, you should be referring to their documentation, all of the public APIs that you have. Even if in case it's a payment gateway like PayPal or Stripe, they will be having their API documentation. You refer to their documentation and you follow their best practices. Also, keep this thing in mind that if any of the API service provider that you have integrated, if it is absolutely necessary that the API token should be hard coded into the app code, it will happen sometimes that it will be demand of the situation that you will have to hard code the API key in the source code. So if you have to do that, if your developer has to do that, please keep this thing in mind that you consider that this API key is now leaked. You know how easy it is for you as a pen tester, as a researcher, as a bug hunter to decompile any of the code. So for that reason, please consider this that when you are intentionally hard coding any of the API key or any of the token into your APK, into your Android code, consider it to be leaked. Do not consider that not a lot of people know how to use 𝗧𝗿𝗶𝗶 or not a lot of people know about APK tool. Only skilled people will be able to do that. Please don't consider this. Consider that when you hard code any of the secret or any of the API key in the source code, consider it to be leaked. That yes, now it has been leaked. Attackers will be using it. So all of the other recommendations that you have, that if you are hard coding the API key in our API, configuration, turn on all of these options so that only you can make the request. For example, if if your API provider has told you that you can perform IP whitelisting here, no matter what API key is coming, if request is not coming from this given list of IP addresses, we will not be performing any of the sensitive action. So if that type of configurations are mentioned in the API documentation, please do them. And please keep this in consideration. It's a very important point. In the actual engagements, clients will ask you these questions. Developers can simply say that Rohan, we cannot remove this API key. If we remove this, our application will fail, our application will break. You will have to find something in between that. So for that reason, ask them that now if you cannot remove this hard-coded API key, so for now we are considering that this API key is now leaked. Let me refer to the API documentation, see if they have got any of the uh, you know way around it or security implementation or best practices for it. We can do that. So that is another thing that we can do. Next thing is the next vulnerability class that we have is regarding the private file access. Private file access here refers to any of the file that is present on your mobile. It may be your internal storage or external storage as you call it, or for Android, it will be external storage or SD card. So we call it internal storage, external storage. Android calls it external storage and SD card. So that memory card that we used to put in, these days not a lot of Android phones would be supporting the memory cards, but some of them they do. So that will be considered as the SD card, like that. So if you as an application have the permission to read the internal files, to read the internal storage, you should be always sanitizing the user input. Now we have been introduced to a term sanitization. Can any one of you help me understand the meaning of the term sanitization? What is sanitization in real life? Sanitization, anyone? Sanitization, anyone? Sanitization in real life. We have just passed the COVID era. We know what is a sanitization, sanitizer. Anyone?
Kind of removing malicious things.
Kind of removing malicious things. What
Yeah.
more? Real life meaning of the term
Uh,
sanitization.
So it's like the precaution to remove germs, like before it can attack you. So
Okay.
that is.
And Sanitization simply means removing unwanted things. Things that are not expected, things that are not required, we will be removing them. We used to use sanitizers a lot. What we used to do whenever we used to shake hands with someone or we used to go out, come back, we had the sanitizer, we used to put it on our hands, rub it, so that all of the germs that we have on our hands, they are killed. We do not have the germs on our hands anymore, at least not alive. So that is sanitizer. The liquid or the chemical that we are using for killing the germs, that is sanitizer. This whole process of killing the unwanted things from our hands, that is sanitization. You know that in your locality as well, the local municipal corporations that we used to have, every day or even sometimes twice a day, they used to announce that now we will be sanitizing the locality. Please keep your doors and your windows shut. The van would be coming in all of the locality, each and every corner of the locality. They will be spraying the sanitizers so that all of the COVID germs, any of the germs, they get killed and they do not impact anyone. So that is sanitization. That complete process is sanitization. Next thumb that we have is input sanitization. Input here means anything that the user enters. For example, you are on the login screen, you enter your email, you enter your password, you hit enter. So that email and password that you are entering, that is an input. When any of the user enters anything, please make sure all of the things that are not required, like when a user is entering the, like let's say phone number, so in that phone number special symbols are not required, at symbol is not required, hyphen symbol is not required, slash is not required. So all of those special symbols that are not required, you first of all remove them and then you send that input for processing. So what we do, any of the application that you are testing, that you are developing, in fact, any of the input that comes from the user, you first remove all of the things that are not required, you sanitize the input, and then you process them. Because if in case we don't do that, what any of the attacker will be able to do, all of the files that are present on our system, on our Android device, with the help of vulnerabilities like path traversal, they will be able to read the internal files. How does that happen? We will be getting to that in some time in one of the upcoming discussions, practically along with that source code review. So for that reason, please make sure that you perform input sanitization. Then having unprotected app components. For you to be able to understand unprotected app components, you need to first of all understand about app components. Any of the Android app that you have, all of the app components that we have discussed, activities, services, broadcast receivers, content providers, intents, intent filters, all of the app components that we have discussed, please make sure that any of the other app cannot access it unless it is absolutely necessary. So if any of the other app can start any of the activity, or it can access any of the service, it can access any of the receiver, you should be considering this to be vulnerable. When in the Android manifest file, for any of the app component, not only activity, most of the people will only be considering activity as exported to be vulnerable. You should be testing for all of the app components that are exported. So in the Android manifest file, when you have a look at any of the Android app component, and if you see that Android exported is set to true, it means that any of the other process, any other Android app, it can also invoke that given app component. So that should not be done unless it is the demand of the situation. Along with that, like just as we have discussed it for the app components, similarly, when in any of the Android application, if you have the custom permissions, like the developers, when they will be checking for the permissions to various app components, they will be having specific permissions that we can read the external storage, we can access the internet, and we can write something to the external storage, we can access the camera, we can access the hardware and make the phone vibrate, the short vibrate, long vibrate, like that. So when you are having any of the custom permission, you should always be testing for the typos in them. Typos means the spelling mistakes. For example, you have like let's say mm, document right. Let's say this is the name of the permission that you have defined, and then when you are actually using the permission, you call it document rights. So when you are defining the permission, you are calling it document right, and when you are using that permission, you are calling it document rights. For us, we can understand that Rohan, document right and document rights are same. For humans, we can understand, we can neglect it. But for Android, it's a machine, it's a computer. Both of them are different. So if you have got any of the so here, hello, can you hear me? Hello.
Yes, we
Yes,
can
yes,
hear.
yes.
I guess there was some network glitch and I was out of the meeting. I was just double checking. So as I was mentioning that you should always be testing for typos, that is spelling mistakes in the custom permission. Like here, as you can see, we have defined the name of the permission as document right. So when we are defining the permission, we are writing document right. And when we are using it actually, we are writing document rights. So that is something that you should be double checking. This is the most common mistake because when any of the code is written manually, typing errors are the most common things to happen. And because it's not practically possible for us as a developer to see the spelling mistakes or see for any of the typos, these types of things happen. So for example, let's say that for this particular permission to get executed, like if you want to use document right, you need to first authenticate yourself and then you will be getting this permission. But if in case you are using document rights, that permission will not be requiring authentication. So in those types of scenarios, when you are defining, now how will you get what all permissions have been defined in the Android manifest file? So in the Android manifest file, you will see in the header, in the first few lines, that these are the custom permissions, and you should search for those custom permissions in the Android manifest file. Like you have document right, see all of the instances of document right and see if you have got any of the typos, like that. Apart from that, you should be testing for all of the content providers, see if they can be used. If in case you have got any of the receivers like broadcast receivers, or you have got broadcast receivers that are sending out the messages, see if they are implicit or explicit. We have discussed about implicit and explicit intents. Implicit is when the particular component is not mentioned, any of the app component based on that particular receiver, it can be invoked. Whereas in the explicit intent, you need to definitely mention that when this type of action happens, like when you receive a SMS, you should be calling this activity, you should be calling this particular component, and this is the next step that you should do. So you should be having explicit receivers that can help you with safeguarding yourself from having insecure invocation. Insecure invocation means when any of the other app or process or component may or may not related to the same application can start that given component. Like it can start an activity, it can start a receiver, it can start a service, that one. So that is unprotected app components. It simply means check what are all of the app components that can be invoked, that can be started by whom. If it is not required, by default set the value of Android exported to false. Then these are some of the common security issues that did not find their way into any of the given vulnerability class, but they are still quite important. For example, we have got incorrect URL verification. These types of security issues are mostly logical. For example, whenever you are making a request to any of the URL, it happens sometimes that you will have to take the input from the user. So like, let's say you have to take the input from the user, and on the basis of that input, you will be opening a new window and you will be opening a browser. If you have told that in the new browser window that will be opening, a new browser activity that will be starting, we can only open those URLs that contain our name. For example, if our website is 𝗀𝗃𝗶𝗶𝗶.in, so what we do, if in case I have to restrict that you can only open those URLs that contain 𝗀𝗃𝗶𝗶𝗶.in. So by myself as a developer, I can understand that I have to give in a condition here that if the URL entered by the user contains 𝗀𝗃𝗶𝗶𝗶.in, then we can open it. Otherwise we will give an error that this URL does not belong to us. Now this is what I'm thinking as a developer, that if the URL contains 𝗀𝗃𝗶𝗶𝗶.in, I have to open it, otherwise I will not open it. But if you have a look at it from the perspective of an attacker, the condition here is that the URL should contain 𝗀𝗃𝗶𝗶𝗶.in. So what I can do, I can take a subdomain, 𝗀𝗃𝗶𝗶.in.attackerwebsite.com. Now if I try to open this URL, what the Android app will understand, that this particular application, this particular user input wants to open this URL. Does this URL contain the 𝗃𝗶𝗶𝗶.in? Yes, it contains the 𝗃𝗶𝗶𝗶.in. Is this okay? This is okay. So these are mostly the logical security issues. So whenever in any of the application you have got URLs that can be controlled by the user, that can be given as an input by the user, see what are the logical checks that you are implementing. See what are the constraints that you are putting, who can accept it, what can be processed, what cannot be processed. So this is a flaw here. This is not something that I would recommend as a security auditor, that if it is the only requirement that it should contain the activist.in. So here you can see this website, this does not belong to the activist.in, but still we were able to get it processed. So when any of the attacker will be a bit creative, they will be able to do that. Then the next issue that we have is cross app scripting. In web, we have got a security issue called cross site scripting. Similar to that, in Android, we have cross app scripting. In any of the Android app, if you can load a URL or a JavaScript from any other app, then these types of issues happen. There is one of the security issue that is most popular, that is insecure deep link. So in that security issue, we will be discussing about cross app scripting, using which we will be able to perform any of the action of our choice. Also with the help of cross app scripting, you can access private internal files related to that Android device. So these are some of the things that you should be keeping in mind when you are testing for, or when you're looking for vulnerable functions in any of the Android code. All of the issues that we have discussed today, all of them will be discussed in the upcoming discussions. They have got modules dedicated to them. One module to cryptography and authentication, one to insecure connection, miscellaneous ones as well, unprotected app components, what they are, why do they happen, how do you test for them, how do you mitigate them, HackerOne reports related to them. We will be discussing again all of these in details in the upcoming session. So for now, for today, I just wanted to give you an introduction that these are the types of security issues that you can expect. This is what you should be paying attention to when you are performing the analysis of any of the source code for vulnerable function here. Even if in case it was a lot of information for you to grasp today, no problem, no need to mug up things. just be present in the upcoming discussions. We will be discussing all of these in detail. Rest assured. Just keep on practicing and referring to the notes and the resources that I'm sharing with you. This file also I'll be sharing with you for your future reference. Okay, so this is what I had in my mind to discuss with you today. Now, if you have any questions or queries, we can take them. Okay. So now if you have any questions or queries, you require my help in troubleshooting anything, you are setting up the lab, or you have any of the general queries, not only related to Android, related to cybersecurity or anything, you can stay back in the session and we can discuss. Otherwise, we may leave the discussion for now and I'll see you tomorrow at 8. I'll be the last one to leave the room. If you have any questions, you can stay back and we can discuss. Please mark your attendance in the chat box so I can share it with the management team. Thank you so much for joining in and I'll see you tomorrow. You may leave the discussion for now if you do not have any questions.
Thank you for today's session, Rohan.
Thank you so much for joining with
Have
me.
a, yeah, have a good night. Bye.
Hi, sir. Rohan, sir. Good evening.
Hi.
Sir, I was missed because I have meetings only Thursday.